Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing nodes between two given level numbers of a binary tree. First, let us take an example. As you can see in this example, we begin printing from level 2 and print nodes till level 4. Now, let us see the algorithm which will assist us in printing nodes between two given level numbers of a binary tree. Let us also have a sample tree to test our algorithm. We pass the root node which is 20 and low and high for the levels between which we want the nodes to be printed. Let us assume that we want nodes to be printed from level 2 to level 4. So, low will be equal to 2 and high will be equal to 4. Note that we are using a queue data structure. We have another variable level to indicate the level number. We initialize level to 1. Also, we have a marker node to indicate end of level. First, we push the root node which is 20 into the queue along with the marker node. Since queue is not null, we enter the while loop. Now we have another node n which will point to the front element in the queue. So n will point to 20. In the next step, we dequeue the front item from the queue. So 20 is popped. Now we check if n is equal to marker. Since it is false, we move on to the second if and check if level is greater than or equal to low. Since 1 is not less than 2, we omit the second if also. In the next step, we enqueue the left and right child of n. So the left child of 20, which is 8, is enqueued into the queue. Now we push the right child of 20, which is 22, into the queue. Since queue is not null, we continue with the while loop. Again, we pop the front element from the queue and assign it to n. So n will now point to marker and marker will be dequeued. We check if n is equal to marker. Since it is true, we enter the first if in the while loop. We print a new line and increment level number. So level will now be equal to 2. We check if marker node is last node in queue or if level is beyond high. Since both are false, we enqueue the marker into the queue. Since n is marker, we don't print it and enqueue its children. So we continue with the while loop. Now n will point to 8. Then 8 will be dequeued. Since n is not marker, we go to the second if and check if level is greater than or equal to low. Since level is equal to low, we print n. Hence 8 is printed. Now we enqueue the left and the right child of node 8. So first we push the left child of 8, which is 4. Now we push the right child of 8, which is 12. Since queue is not null, we continue with the while loop. Now node will point to 22. In the next step, 22 will be dequeued from the queue. Since n is not a marker, we move on to the second if. Since level is equal to 2, we print n. So 22 will be printed. Now we enqueue the left and right child of n. Since 22 does not have both left and right child, nothing is enqueued. We continue with the while loop. Now n will point to marker. Marker will be dequeued. Since n is equal to marker, we print a new line and increment level number. So level will now be equal to 3. We check if marker node was last node in queue or if level number is beyond high. Since neither is true, we enqueue marker into the queue. We continue with the while loop. Now n will point to 4 and 4 will be dequeued. Since n is not marker, we move on to the second if. In the second if, we check if level is greater than or equal to low. Since 3 is greater than 2, we print 4. Now we will enqueue the left and right child of 4. Since 4 does not have any child, nothing is enqueued. Since queue is not empty, we continue with the while loop. Now n will point to 12. Then 12 will be dequeued. Since 12 is not marker, we move to the second if and check if level is greater than or equal to low. As it is true, we print 12. Now we will enqueue the left and right child of node 12. So 10, which is the left child of 12, is enqueued. Next, 14, which is the right child of node 12, is enqueued. Since queue is not null, we continue with the while loop. Now n will point to marker. Then marker will be dequeued. We check if n is equal to marker. Since it is true, we print a new line and increment level. So level will be equal to 4. We check if queue is empty or if level is greater than high. Since both are false, we push marker into the queue. Now we continue with the while loop. N will point to 10. 10 will be dequeued. We check if n is marker. Since it is not, we move on to the second if. Now since level is equal to high, we print n. So 10 will be printed. As 10 does not have any children, nothing is enqueued, and we continue with the while loop. Now n will point to 14. 14 will be dequeued. Since n is not null and level is greater than low, we print 14. Again, 14 does not have any child, so nothing is enqueued. We continue with the while loop and n will now point to marker. Marker will be dequeued. Since n is equal to marker, we increment level. Now the queue is empty, or we can say level is greater than high. So we break and control will come out of the while loop. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in a tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.